Good morning, everybody. Welcome to Calculus 2. I hope you had a great break and are here back ready to go. So the first thing that I'll say to you about Calculus 2 is it is significantly harder than Calculus 1. So congratulations on making it and prepare yourself because you made it. I also think that Calculus 2 is harder than Calculus 3. A lot of Calculus 2 is concerned with this idea of finding antiderivatives. So for example, if I ask you to take the derivative of x to the third, the answer is 3x squared. Going the other direction, if I hand you the function 3x squared and I say somebody took a derivative and got 3x squared, go backwards. Okay, so clearly in this case, 3x squared came from x cubed, right? But going backwards is significantly harder than going forwards. Going forwards involves just knowing a small handful of derivative rules. They're on page 9, most of them anyway. So open to page 9 real quick in the big packet. And you will find this thing at the top that says Strategy Guide for Differentiation. And so in the table at the top of page 9 is derivative rules for a small collection of functions. In addition to these, like here are derivatives of some specific functions. You need to know how to take derivatives of sums of functions and differences and products and quotients. I need to be able to handle constant multiples. And then need to take care of chain rule derivatives, where one function is inside of another function. But largely that's it in terms of calculating derivatives. It's a very small list of things to do, but going the other direction, like I said, is much, much harder. I promise you that if you are not super comfortable with going the derivative direction, the easier direction, a lot of this is going to be a struggle for you. So in the next week or so, dust off, like all of your old derivative rules, maybe from last semester or whenever, and like practice derivatives so that we have a good chance of doing the very hard antiderivative direction. Okay? All right. How's that for scaring you in the first 30 seconds of a math class? All right, so we got just a couple of logistical things we're going to tackle before we jump into the math. So first of all, officially on your schedule, there is something called studio time. For most of you, you're quite aware of what this means, but on the schedule for you, it says 8 to 8:39 in the math studio right across the hall. That is optional, but highly recommended as a good place to get your homework questions answered. But officially, we're going to start here at 8:40 every day, okay? All right, next I want to take a quick look at the syllabus. Everybody should have one of these in front of them. So make sure you grab one of these. You've got my contact info there, including my work number and my cell phone number. And my cell phone number is there because it's okay for you to call me. Sometimes students will struggle for like 1 hour on a question, and I don't think that's a good use of their time. If you call me, maybe in 60 seconds, I can give you one little hint that will open the door to that question and possibly the rest of the questions if all of the homework relies on this one little idea that you didn't quite get. So call instead of struggling, struggle a little bit, but then call, don't struggle for an hour, all right? So many of you already have the textbook from Math 201, same textbook is going to be just fine this semester. If you don't have the textbook yet, I would encourage you not to buy the 6th edition, but to buy the 5th edition of this textbook. It will be much, much cheaper. I have to go online to do that. Because there are 2 different textbooks that you can use, there's 2 sets of homework assignments. So let's take a quick look at the homework assignments. It's on the inside of the last, here? No, last page, or possibly the back of the last page. It's a chart with 2 columns in it on the syllabus. So 5th edition homework is on the left, 6th edition is on the right. Earlier today, 3 of your classmates helped me restaple a much smaller homework assignment, and that's what you're looking at right here. Right, so just like last semester, I cut the homework way down, did the same thing this semester for Calc 2. So there are the homework assignments. And one little change in a policy from last semester. Last semester, I accepted old homework all the way up until the test that covered that material. I don't think that did some students a lot of favors because some students got in the habit of waiting until the last minute, like right before the test, and then they would hand in like 7 homework assignments, but were probably quite uncomfortable with the material for like the 3 weeks that we were working on that test material. So new policy, it's laid out in the syllabus. I will accept homework up to 1 week late. Up to 1 week late. I know sometimes life gets in the way. My expectation is that the homework I assign tonight, you're going to show me on Monday. but sometimes things are busy, and I recognize that. 1 week, but after that, I won't take the homework. So this is my effort of trying to strongly encourage people to really stay consistent and up to date with the homework. Yes?
Like until Wednesday we have, or until next Friday?
Friday. Yeah, so tonight's homework assignment, you can take it until, wait, no, that's not right. The homework is due on Monday, so I'll take it the following Monday.
Oh, I got it.
Yeah, 1 week late. Yeah, okay, good. All right, so I think that's good there. If we go back to the back of this particular page, you'll find a very dense spreadsheet looking thing, which I will call our syllabus calendar. I'm going to pull this up at the start of every class. I'll pull up an Excel version of it. But this tells you where we are and where we're headed for the whole semester. Project number 1 is assigned today on January 27th, so make sure you grab a copy of Project 1. There's a little picture on the front middle there. Everybody have the project? So projects this semester are going to be different from the ones from last semester. If you had math Calc 1 with me, last semester there were 6 very involved, very intense projects. Here there are going to be 9 much shorter projects. Additionally, I'm never going to hand you 2. I'm just going to hand you 1, and when you give it back to me, I'll hand you the next one, all right? So project 1 is assigned right now. Typically, the projects will be due about a week later, so February 3rd. 1 week from today is when that project is due. All the projects you are welcome, encouraged to work with each other. Just make sure you credit the other people that you worked with, okay? Questions on that? Yes?
Are we not doing check-in days anymore?
No, not doing the check-in days. Okay. All right, I think that is good. Okay, so let's jump in back on this big packet. We're going 3 pages down the road to page 12. Page 12 of the big packet. Okay, with our daily summary. In this class, we summarized Calculus 2, and we reviewed differentiation, that is taking derivatives from Calculus 1. We will take 2 days only to review, today on derivatives and next class on definite integrals. So in 3 lines, a brief summary of what is Calculus 2. Number 1 is evaluating integrals, techniques of integration, and problem solving. Topic number 2 is applications of integrals, applications to geometry, physics, economics, probability, a few other applications as well. And then finally, topic number 3, sequences and series. What do you get if you add 1 plus a half plus a quarter plus an eighth plus ... forever? This looks quite a bit different from all the antiderivative stuff in the first 2 topics. We will somehow relate these things together at the end of the semester. Okay, so taking a look at number 2, our quick review on derivatives. How do we find a derivative if we're given a table of values, a graph, or a formula? We're going to do each of those right here. In all 3 cases, we're going to try to estimate, how do we say these symbols? F prime of 2. We're going to try to estimate F prime of 2. So part A, we've got a table of values when x is 1, 2, and 3, f of x is 1, 4, and 9. And then we're just trying to estimate f prime of 2. Let's draw a quick sketch, very rough sketch of those 3 points. So 1, 1. Go ahead and roughly sketch the other 2 points. Don't even really need to worry about scale. So we've got 3 points plotted, and we're trying to estimate f prime of 2. So presumably there's some curve that hits these 3 points. I mean, I'm just going to draw something that kind of follows that trend, but I don't know that it looks like that. It could look wildly different from that. There's lots of things that hit those 3 points, but we'll just assume it looks something like that. And f prime of 2, when I say estimate that, what geometrical thing am I trying to estimate? What about the tangent line? Slope of the tangent line. So draw a little tangent line. You've got just a rough sketch there. Don't even worry about a straight edge, just a rough tangent line at the point x equals 2. And we're trying to estimate that number. But we have hardly any information here. We just have coordinates of 3 points. So how about we guess that the slope of that tangent line is roughly the same as the slope of the tangent line connecting, sorry, is the slope of the secant line connecting the point at x equals 1 and the other point at x equals 2. Or maybe we choose to connect the points at x equals 2 and x equals 3. Or maybe we choose to connect the points at x equals 1 and x equals 3. But whatever you choose, we're just connecting 2 of the 3 points that we have. Let's do the outer ones, but there's a few different answers that are fine here. So we're doing a slope here, change in y over change in x. So f of 3 minus f of 1 over 3 minus 1. Upstairs, f of 3 is 9 minus f of 1. That's 1 divided by 3 minus 1, 8 over 2, which is 4. Okay, that's it. That's our estimate. I would accept 2 other different answers from that one. Like I said, you can connect any 2 of the 3 points that we have.
The further the points get away from each other, the less accurate.
Theoretically, but we have so little to work with. Okay, so that's how we estimate from a table of values. Number 2, we're again estimating f prime of 2, but this time we have a lot more information. We've got a whole graph. So go ahead and put a dot at x equals 2. 2, so that looks like it's right there. And this time, let's actually use a straight edge. So grab my folder if you want, or if you have a ruler or something, use a straight edge. Draw your best tangent line at x equals 2. And again, we're trying to estimate the slope of that tangent line. And so this is going to be a matter of counting boxes, right? So go ahead and count some boxes. Slope we know is rise over run. So estimate the slope of that line by counting boxes. Okay, so I'm going to count my boxes, which are probably a little bit different from your boxes, right? Because we all drew a slightly different line. So for me, I've got one nice point up there at 2, 4. I've got another point down here. It looks like maybe it crosses the x-axis at 1. That's my tangent line. Yours might be different. So if I assume this is the point down here at 1, 0, then I can do a calculation. 2, 4, and 1, 0, right? So again, change in y over change in x. So it's 4 minus nothing over 2 minus 1. Which is 4 over 1, which is 4, okay? But again, I've got flexibility. I can give full credit for different answers as long as they're reasonably close to the right answer, which I'm not saying the right answer is 4. But I'm not saying, right? We don't know anything. We're just estimating. Okay, and then finally, the moment we've been waiting for is for me to give you the formula, right? This is what a lot of people think of as calculus 1. It's like, oh, if you give me a formula, I can apply the derivative rule. That's a big part of calculus 1, but there's other ways to calculate derivatives. We just did 2 of them. So let's go ahead and find f prime of 2 here. Before we do, we need to know f prime of x, generic x. What is it? 2x. And so therefore f prime of 2 is 2 times what number? 2, right? Just replace the x with the 2. And so we get 4. So that's calculating the derivative in 3 different ways. Fair? Okay, so let's move on to the next page, which is the start of the group activities. This will look very familiar to you if you had me last semester. So you're going to be working very closely with your neighbors throughout the course. Feel free to change tables at any point for any reason. First thing you're going to do is introduce yourself. So fill in the names of the people around you. If you're sitting at a table by yourself, maybe move. And then you're going to start working on these problems. And the problems continue after this page, and they continue several pages into the future. I'll stop us about 5 minutes left in class, and I will walk around and help if I can. Go ahead.